This is Gail Kovac for Gresham Barlow School District, Summer School, High School Credit Recovery. We're in geometry. This is learning target number 1. I can identify and transform figures through translation. So let's talk about transformations a little bit. A transformation is a movement that you do onto a figure to change its position or rotation. We are not changing the way the figure looks. We're not stretching it or shrinking it or disfiguring it in any way. We're just moving it somewhere. So the before and the after are congruent. They're still going to be the same shape, just in a different location. There's different kind of transformations we can do, and one of those is translation, which is what we are doing today. I also call this sometimes a slide. You are taking the shape and you are just sliding it up or down, left or right, and it will be in a new location. It will still even be in the same orientation, so it won't be twisted around, just kind of slid around into a new spot. So let's try the problem on the left. It says to describe the translation below. On this coordinate plane, you can see two triangles. They are congruent triangles. They are the exact same shape and size, but they are in two different spots. So the triangle JKL, which is this top one right here in black, that is your original. That is the before. The blue one, and if you have a photocopy, it might not look blue, it might look black, but the one underneath is called J prime, K prime, L prime. That is your after figure. The little tick marks on the side indicate that it has been changed. So this is the after figure. So the one on top is before and the one on the bottom is after. If you were to move it again, they might add another tick mark. So that would be like J double prime, K double prime, L double prime. But this has only been moved once and we need to describe that movement. So remember when we plot points on a coordinate plane, the x, or the horizontal axis here, goes first, x right here, and the second one, which is your up and down, that's your y, so the y goes second. So we're going to be describing how this figure moved either forward or backwards first. If it went to the right, that would be in a positive direction. If it moved to the left, that would be negative. And then the y is your up and down. How did it move up or down next? Up would be positive and down would be negative. So let's start here. I'm going to take a look at point J first. Here's the original point J. And it is mapping to J prime. We are mapping one point to another because that's how we describe figures, is by their endpoints. So J started up here and then it ended down here and a little bit forward at J prime. So let's describe first if it went forwards or backwards along the X, right or left. So this point went forward 1, so that's +1 along the X. And then it went down along the y, and that would be negative. So it went down to J prime. So that was down how many? 1, 2, 3, 4. It went down 4 along the y. All of the points also did that. It is the same transformation or same mapping to all of the endpoints. That's what allows it to remain a congruent figure. So from K to K prime, that was also forward 1 and down 4. And from L to L prime, that was also forward 1 and down 4. So let's start with our X. What did we do with the X coordinates? The X coordinates went forward 1. So to all of the X components, we are adding 1 to bring it forward 1. And then the Y component from there, we went down 4, so that is subtracting 4. So from J to J prime, we take our Y component of our coordinate point and we subtract 4. So this is Y subtract 4. And now if you had another point, you could follow this same procedure to find out where its mapped point would go. So for example, here, this point J is at 2, 0. What we should do to get j prime down here is add 1 to x, according to this, and subtract 4 from y. So let's see if that's true. Let's add 1 to 2, and we get 3. And then let's subtract 4 from y. That would be negative 4. Let's double check that, in fact, my j prime point, my translated point, is at 3, negative 4. So here's 1, 2, 3, and 1, 2, 3, 4. Yes, that is the correct coordinate point. So you can describe the change to all of the x's and all of the y's to go from your original JKL figure to your translated J prime, K prime, L prime figure. Now on our second problem, it wants you to actually translate the figure as described by this translation here. To all of the x components, we are going to subtract 2. That will scoot it backwards or to the left 2. And to our y components, we're going to add 3. That will take it up 3. And we're going to do that to every single point. Now I can just count the points here. Let's see, let's start with j. I'm going to subtract 2, so that's going to take it this way. 1, 2, and then I'm going to go up 3. 1, 2, 3. This right here is where j prime should end up. Let me do this in blue here. All right, so here's your j prime. Let's do the same thing to the other 4 points. M is going to go backwards 2. That's negative 2 for x. And up 3 for y. 1, 2, 3. Okay, so that's where M prime is going to land. Mapping M to M prime. Let's do the same thing for E, backwards 2 and up 3. 1, 2, 3. Right here. Here's E prime. And lastly, we've got X, backwards 2, 1, 2, and up 3. 1, 2, 3. This is where X prime should land. Now, if your translations are small enough where you can just count across the coordinate plane, then you can most certainly do this. If, however, you've got large figures or you're just given the coordinates, then you would need to actually add and subtract to the coordinate point values to try and figure out where the translated figure ends up. But in this case, we can just count steps here, and I'm going to connect J prime, M prime, X prime, and E prime to get my translated shape. Now, you'll know you've done this correctly if your translated shape here is congruent to your original. If it is the same shape and same size, just shifted over. I can see J and E are 1 point across here. There's J and E. J prime and E prime also does the same thing. E and X, those lines here are parallel to each other and they're the same distance. So is MX and M prime X prime and J M and J prime M prime. So your after figure should look the exact same as your beginning figure. And this is translations or transforming figures from just sliding them around.